My name is Kevin Soderholm. I'm a data scientist from the banking industry, but for my project I chose to predict hospital readmission in an application that would be patient-facing in a hospital setting. I've been following Kumo since they started, and when the RFM white paper was released, it was honestly pretty mind-blowing to me, and I couldn't really wrap my head around a foundational model for relational data. So it was just something I wanted to get my hands on and try. So hospital readmission was something that I had worked on about 10 years ago. I published research with a hospital system doing something similar, but this time I just tried a completely different techniques and made it more about the product and less about the, the statistics behind it. So I'm happy with what I got and excited to present it. As I'll explain in the presentation, I think KumoRFM is very critical for the type of product I built that required on-the-fly predictions at the patient level in a way that is very flexible and can scale a lot better for multiple different use cases compared to the traditional machine learning model development process. This is a quick demo of the hospital readmission risk assessment application. This app was built for the KumoRFM Hackathon. There are 5 steps for the patient to complete as part of their normal discharge process in the hospital. First is to verify the patient. Next is to review the admission overview. This has patient information, information related to the diagnosis, as well as lab results and medications prescribed. Next is to get prediction. First, we can choose predict readmission within how many days. I'm going to leave it at 30, which is the common definition for an early readmission. When I click predict, I get a variety of info related to the prediction. So the underlying probability has been bucketed into low, moderate, and high risk. And you can see this patient is high risk. On the left-hand side, we see top contributing factors for that risk level. And on the right-hand side, we've triggered a secondary prediction to predict the most likely readmission diagnosis, which tells the doctor the most likely reason that they would have to come back. Next, we're going to generate a video. And while this is happening, all the information above is packaged up into context that is fed in a prompt to an LLM to say, read this context and generate a script for a virtual doctor to read that would describe to the patient their risk level, the top contributing factors, and what their next steps are in the discharge process. The script generated from the LLM is then fed to an avatar AI video to read it back to the patient. These are between a minute and a minute and a half, and here's a quick snippet.
The urgency of your admission and the high CRP level indicate that your body is still fighting the infection. Given these factors, your doctor will review your case in more detail before discharge. They may suggest a slight
Try and create a product that is useful for the real world and think about the user experience and put some effort into that part of it.